Hello everyone, welcome to the next chapter. In this chapter, we shall explore heat transfer analysis in a mixing pipe. This one is relatively simple compared to the previous cases. Let us explore. We shall see the problem definition. As you can see in this image, cold water enters from the left side and hot water enters from the smaller diameter pipe on the top side, and the mixed flow leaves on the right side. Okay, we shall see the flow parameters. The fluid material is water for both cases. Cold inlet temperature is 25 degrees Celsius and the cold inlet velocity is 0.4 meter per second. And the hot inlet temperature is 80 degrees Celsius and the velocity is 0.6 meter per second. The outlet pressure is 1 atmosphere, and we shall specify convective heat transfer coefficient on the external surface of the solid body. This will be 5 watt per meter square per Kelvin. In this problem, we will include both the fluid domain as well as solid domain surrounding this. Let us see the pipe dimensions. The cold inlet pipe is having an internal diameter of 4 inch and the hot side is having 2 inch. The pipe material is steel. We have to find out the outlet water temperature and the temperature distribution on the solid body. Next, coming to the approach, we shall solve this problem in two methods. In the first case, we will solve both solid and fluid domain together in Ansys CFX. In the next case, we will solve the fluid domain in CFX and transfer the temperature data to the solid model inside steady-state thermal. Steady-state thermal is commonly used for heat transfer analysis in solid bodies. There are some options available to model fluid physics, but mainly it is used for solid bodies. In this case, we will do the CFD analysis first and map the temperature data from CFD to the interface region on the solid body. Okay. Next, we shall do a quick calculation to find out the outlet flow temperature. The energy balance equation is shown here. The energy flow rate at the inlet for both cold and hot will be equal to the energy flow rate at the outlet, and the energy is equal to mCp/T, where m is the mass flow rate, Cp is the specific heat and T is the temperature. We can calculate mass flow rate from this formula rho AV, where rho is the density, A is the cross section area and V is the velocity. For the cold flow, the diameter is 4 inch and for the hot flow the diameter is 2 inch. The velocity is 0.4 meter per second for the cold water and 0.6 meter per second for the hot water. Let me show the calculation. We have calculated mass flow for the cold inlet as well as hot inlet. The density, diameter, cross section area, velocity are given here. Mass flow rate is calculated. The inlet temperature for the cold inlet is 25 degrees Celsius and for the hot inlet it is 80 degrees Celsius. Finally, the mass flow rate at the outlet will be sum of these two inlets, and the final temperature is given by m dot T1 plus m dot T2 divided by overall mass flow rate, which is equal to 313.5 Kelvin. This is nothing but 40 degrees Celsius. Therefore, the outlet temperature is 313.15 Kelvin. This is nothing but 313 minus 273, which is equal to 40 degrees Celsius. Okay. The values are listed here. Mass flow rate at cold and hot inlet, the formula T1, T2 and the final output temperature T3. Okay. Moving ahead, we shall simulate the case in Ansys CFX and compare the results of outlet temperature. We shall go to workbench.